what was our equation? We had two equations for ellipses, depending on if they were long and short or if they were tall and skinny. What did our equations look like? X minus h squared over a squared plus y minus k squared over b squared equals 1. And we had to have the rule that a was bigger than b. And then we had another letter called c, where c squared was a squared minus b squared. What do these letters A, B, and C, those tell you something very important about the ellipse? Well, let's start with H and K. What's H and K first? H and K gives you the center. What about A, B, and C? What were they all about? Okay, so A is always the bigger one. So A tells you the length of the 2 times A is the length of the major axis. And B tells you the length of the minor axis. 2 times B is the length of the minor axis. And how about C? C was the distance from the center to a foci. So 2 times C is the distance between the two foci. And then sometimes we had the bigger number under the y. Sometimes we had a squared over here and b squared over there. How did that change things? So this ellipse, the way it's written with a, the bigger number here, this one is long and skinny. If the bigger number is under the y, then it's, well, I'm sorry, this one's long and short. With the big number under the x, you're long and short. If the big number is under the y, then you're tall and skinny. All right, so the kind of problems I wanted to do, they're going to give you some information. For example, they might say, the vertices are -7, 0 and 7, 0. And the foci are -3, 0 and 3, 0. From that information, it wants you to find the equation of the parabola. Not a parabola, ellipse. This is an ellipse. What do you do? Well, it might be a good idea to start by just drawing a really rough picture. So if my vertices are here, -7, 0 and 7, 0, where's the center? The center is right halfway in between, so the center has to be at the origin. Is this a long and short ellipse, or is this a tall and skinny ellipse? Long and short. How do you know this is long and short? Because these are the vertices, which tells you this has to be the major axis. So this ellipse has to look something like this. The vertices would be given here and here. What's that? Co-vertices. If these were called co-vertices, then they would be here and the vertices would have to be up and down. Co-vertices would be these points here. Co-vertices. All right, well, I think then we should know the A number. A is 7. Why is A 7? From the center to a vertex is 7 steps. So A is 7. What other letter do I know? C. What's C? How do you know C is 3? Because our foci are here and here, 3, 0 and -3, 0. C is the distance from the center to a focus. So C has to be 3. What's A? Well, we know A. What's B? We don't know, but we can figure it out. How do we figure it out? c squared equals a squared minus b squared. So 9 equals 49 minus b squared. So minus 40 is minus b squared. So b squared is 40. And truthfully, I really don't want to know b. I really want to know b squared anyway. So I'm just going to leave it as b squared equals 40. Why do I want to know b squared and not really b? In my equation up above, I have a b squared, not a b. So I might as well just leave it as b squared. Grace?
C equals 3 because that's the distance.
C is, right, C is the distance from the center to the foci. So in this case, that's just 3 steps straight to the right. Okay? So it looks like my equation is x squared over (49). Make sure you do 7 squared there. 7 squared is 49. Plus y squared over 40, because b squared was the number 40, equals 1. There's the equation of that ellipse. I don't need h and k because they're 0 and 0. Correct. All right. How about if I told you the center was, I don't know, somebody give me a nice point. What's your center? 5, 5. Let's make it 5, 4, just so they're different, so we understand where h goes and k goes. And then a vertex. Right, this is the final answer. That's the final answer for that problem. Vertex is going to be at 5, 12. And a covertex is going to be at 7, 4. Draw a picture. It's always a good idea to draw yourself a quick picture. All right, so the center is 5, 4. So that's right about here. 5, 4. And then my vertex, it says I got to go to 5, 12. So there's 5, 12. There's a vertex. And a covertex is over here at 7, 4. Long and short, or tall and skinny? Tall and skinny. And you can see that from the picture that it's got to be kind of like this. All right. Do I know the A number? Yeah. What's the A number? 8. Why is the A number 8? Because it's this distance. And if I start at 5, 4 and I go up to 5, 12, I went 8 steps straight up. So A is 8. Do I know B? Yeah, B is 2 because B is this distance. So B is 2. Distance from 5, 4 to 7, 4 is 2. Do I know C? I can figure it out, but I really don't need it to answer the question, do I? To answer the question, what do I need? I need A and B. So this one is going to look like y minus k squared over a squared. This one is tall and skinny, so the big number is on bottom. Plus x minus h squared over b squared equals 1. You could switch them around. You just need to make sure that you put the big number under the y's this time. So you could write the y's first. You could write the x's first if you wanted to, and then the y second. But you do have to make sure the big number is under the y's. So it looks like my answer is y minus 4 squared divided by 8 squared. 8 squared is 64. Plus x minus 5 squared. You could leave it as 8 squared if you wanted to. Either way is fine. I chose to write it as 64 today. B was 2, so this is 2 squared, which is 4, equals 1. K and H come from the center. K is always the y value of the center, and H is always the x value of the center. So this right here, this is H comma K. No, in fact you don't want to. When you write the equation of an ellipse, you want it written in this form. Because right away you can look at this and you can say, well, I see my center is 5 comma 4. I can see this gives me my major axis length, this gives me my minor axis length. So no, you really don't want to do anything with it. You really want to leave it like that. I mean, there's lots of stuff you could do. You could move this over. You could multiply by the 64. You could do square roots. But you really don't want to do any of that. You want to leave it just like that is the way to write it. Other questions? All right, one more. I think we did something like this the other day, but we'll do it anyway. What if I gave you x squared plus 4y squared minus 6x plus 8y equals 2. You should look at that equation and you should immediately know that that is an ellipse. How do you immediately know that is an ellipse? It's got an x squared and a y squared. The coefficients are not the same. One's got a 1, one's got a 4, but they are both positive. If they're both positive, then you do get an ellipse. If one is positive and one is negative, you get a hyperbola. And we'll talk about hyperbolas here in just a few minutes. Okay, what do I want to know? I want to know the center. I want to know vertices. I want to know co-vertices. And I want to know foci. So I want to know 7 things because there are 2 foci, 2 co-vertices, 2 vertices, but only 1 center. What do you do? You have to complete the square. All right, so we're going to rewrite this. This is x squared minus 6x plus 4y squared plus 8y equals 2. So I rewrote it. I put the 2 x things next to each other. I put the 2 y things next to each other, and that 2, I just left that 2 there. We need to complete the square on the x's. I take negative 6. I divide it by 2, and then I square it, and I get 9. So I have to add 9 to both sides. What did I do there? You take this number, the negative 6. You take negative 6, you always divide by 2, and then you square that answer. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. You have to add 9 to both sides. And what happens now is the x squared minus 6x plus 9 factors in a really, really good way. How does x squared minus 6x plus 9 factor? X minus 3 squared. So this is x minus 3 squared. So that's called completing the square because we wrote the x's in a perfect square. Now, unfortunately, completing the square on the y's is a little bit more complicated. Take out a 4. What we have to do here, in order to complete the square, this first number always has to be the number 1. It's not. It's the number 4. So we're going to factor out a 4. We're going to write this as plus 4 times y squared plus 2y. And I'm going to leave a spot there. I'm going to leave a spot to put in my magic number. And over here on the right, 2 plus 9 is 11. Okay, for the y's, what's the magic number? 1. Why is the magic number the number 1? I take this middle number 2, I divide it by 2, always divide by 2, and then square it. 2 divided by 2 is 1, 1 squared is 1. So I put a plus 1 there inside my brackets, but it's actually a plus 4, because since it's inside the brackets, I'm multiplying it by 4. So if I do a 4 on the left, I have to do a 4 on the right. That one's a little tricky. That's very easy to mistake. It's very easy to put a plus 1 here on the left and put a plus 1 on the right. But you got to remember that this 1 is inside the brackets. I'm really doing a 4 times 1. So I need a 4 times 1 on the right. All right, so we have x minus 3 squared plus 4 times y plus 1 squared equals 15. Say that again. Well, you can't complete the square just ignoring this 4, because then you'd be dealing with the number 8. Now, you really need to factor the 4 out. This first term, when you complete the square, that really needs to be the number 1 right there. You really need to factor that 4 out. All right. This isn't quite written in the form we need it. What do we need now? Divide by the 4. Close. I really need to divide by the 15. Why do I need to divide by the 15? I need a 1 right there. All right, so I have to divide by 15. X minus 3 squared over 15 plus 4 over 15 times y plus 1 squared equals 1. That's very, very close, but it's still not right. Because I need the x's divided by a number, and then I need the y's divided by a number. So how do I take y plus 1 squared times 4/15 and write it as y plus 1 squared divided by some sort of number? I could have. There, I'll make a big fraction bar. Now it's on the both. It can go in either place, it doesn't matter. The problem still would be, if I wrote it that way, I'll write it that way, x minus 3 squared over 15 plus 4 times y plus 1 squared over 15 equals 1. Still got a problem, and the problem is I still can't be multiplying by this 4. Right, our formula has x squared over a number, y squared over a number equals 1. So I still have to fix the 4 in either case. What do you do? No, P is for parabolas. P's go with parabolas. There's no P's in ellipses. Oh, actually, there are P's in ellipses, but that's how you spell it. Anyway. Divide by 1/4. Yeah, you're right. So we're going to write this as x minus 3 squared over 15 plus y plus 1 squared divided by 15 over 4. Multiplying by 4 is exactly the same as dividing by 1/4. Because to divide by 1/4, you would flip and multiply. That forces you to multiply by 4. So that can happen sometimes. Sometimes you have a 4 times a number. You're going to have to move it down to the bottom like that. Equals 1. All right, so that one's kind of a mess. But we can start answering the questions. Where's the center? 3, -1. The x is 3, the y is -1. Center. 3, -1. kind of ellipse is this? Is it long and short, or is it tall and skinny? Long and short. Why do you say long and short? Because 15 is bigger than 15 over 4. So the big number is under the x's. Okay, so what's my a value? A is the square root of 15, because a squared would be 15. So if I want to find my vertices, I start at my center. Which way do I go? Left or right or up or down? I have to go left and right because we decided this was long and short. So I'm going to start here at 3 comma negative 1, and I have to go right by the square root of 15. So if I start at 3 comma 1 and I go right square root of 15, where am I? Say that again.
3 comma negative 1 plus square root.
If you add square root of 15 to the y's, aren't you going up?
Oh yeah.
I want to add to the x's because I want to move left and right. So our vertices, one of them would be 3 plus the square root of 15 comma negative 1. That would move me square root of 15 steps to the right. How would I move square root of 15 steps to the left? Subtract. So typically we write this way. 3 plus and minus square root of 15 comma negative 1. That's how we would typically write our vertices. How did I know a was the square root of 15? Well, two things. First off, I had to look at these two numbers and decide which one was bigger. This one's bigger. And remember, this number is a squared, so a squared is 15. So I took the square root on both sides. A is the square root of 15. All right, how about the b number? B squared would be 15 over 4. So b is square root of 15 over 2. Where 4 happens to be a nice number, it's 2. All right, so to find the covertices, I start at the center, 3 negative 1, and which way do I go? Left and right or up and down? Up and down. So I'm going to add to my x number or my y number? I add to the y number. So my covertices are going to be 3 comma negative 1 plus or minus the square root of 15 over 2. Depends on which way it goes. Yep. Goes the other direction from the vertices. That's right. If your vertices are going right and left, your covertices go up and down. If your vertices go up and down, your covertices would go. Depends on if it's tall and skinny or if it's long and short. In this case, we're long and short. So we'll give these two. All right, finally, to finish this one off, I need to find the foci. To find the foci, I need to know what? C. So I know that c squared is a squared minus b squared. It's always a minus b. Yep, always a squared minus b squared. Always, always, always. So c squared is 15 minus 15 over 4. Because a squared is 15 from our equation, and b squared is 15 over 4. What's 15 minus 15 over 4? Well, something over 4. Do you agree with that? How about 45? Because you would get a common denominator, you would multiply this one by 4. That would be 60. 60 minus 15 is 45. So C is square root of 45 over 2. Alright, so finally, to find my foci, I start at the center. And which way am I going? Am I going left and right, or am I going up and down? Left and right. Why left and right? Because again, we're long and skinny, so the vertices, the foci are to the right and to the left of the center. So again, I start at the 3. I add and subtract square root of 45 over 2, comma, -1. There's my foci. Questions on that? C squared is 45 over 4.
Right.
So then I had to do the square root. So I did square root of 45 over it. And when you do your foci, it's the C number, not the C squared number. Just like it was the A number, not the A squared. So I had to use square root of 15, not regular old nice 15. Other questions? All right, our last conic then are known as hyperbolas. And again, hyperbolas are going to come in 2 classes. We're going to have hyperbolas that go this way. They go left and right. These look kind of like they're 2 parabolas going opposite directions, but again, they're really not parabolas. They kind of look like that. Right here, we're going to have our point halfway between, and this point will be called the center, which will be h comma k. All right. Then we're going to have these 2 points right here, this one and that one. Those points are called vertices. Those are called this is a vertex. This is a vertex. How far is it from the center to the vertex? That distance is called A. That's correct. Inside of our hyperbolas, we're going to have points here and here, and these are called the foci. So this is a focus, and this is a focus. How far is it from the center to the focus? That distance is called C, just like it was for an ellipse. From focus to center is called C. And then finally, up here, there are some points. These points don't fall on the ellipse, but this distance here is called B. And here's what happens. If you draw this rectangle that goes through this point B and through the foci, you get a box. And if you go to the corners of these boxes, we get an asymptote of this graph. So hyperbolas have asymptotes. And I have to look up to make sure I get the right equation here. The equation of this asymptote is y minus k equals plus and minus b over a times x minus h. So those are the equations of the asymptotes. And the equation of the hyperbola itself is x minus h squared over a squared minus y minus k squared over b squared equals 1. So you'll notice this equation of this hyperbola is almost exactly the same as the equation of an ellipse. What's the only difference? It has a minus. And the other formula we have here is how to find c. C squared is a squared plus b squared. It turns out you get exactly the Pythagorean theorem there. Say that again. This is the equation of these asymptotes. So there's two of them, one with a positive slope, one with a negative slope. So this is for a hyperbola that opens left and right. What do you think would be different if we wanted a hyperbola that opened up and down? We do two things. One, we switch the a's into b's, and we switch the plus sign. So if the x's are positive, it's going to open left and right. If the y's are positive, it's going to open up and down. So the other equation you're going to see here, you're going to see y minus k squared over a squared plus x minus, not plus, minus x minus h squared over b squared equals 1. This would open up and down. And then your formula for your asymptotes changes slightly. It's y minus k is plus or minus a over b times x minus h. The a and the b flip. Yep. I have some really, really good news for you. What's the really, really good news for you? No, this is on the test. You do not have to memorize the formulas. I will give you a formula sheet which has all these formulas on it. That's the really, really good news. It will be on the final, I promise you that. But I will also give you the formulas.
Is the final like all
The final will look very, very much like the other exams you had this semester. So it'll be fill in the blank. So I'll give you a question, then there'll be a blank, and you'll fill it in with information. Okay. Well, that's a great question. Will we get a review packet? You mean like this right here? Yeah, I think you will.
So, is there homework for this section?
There is homework for these sections.
Where are the extra points? Can they go to like...
There are no extra points.
You don't get extra points for doing homework?
No.
What kind of incentive is that?
You have to learn. You want to learn so you do well on the final. There's no extra credit for the final. The review...
For the final, I was asking if we could like take those points and put them to like the lowest quiz graders.
No, because I dropped a whole bunch of quizzes. All right, so the review packet is very skinny. It only has one piece of paper. How is that possible? Well, this review packet is only for the new stuff. It's only for the stuff since we did since the third exam. So what do you do to study for the first 3 exams? Go through for your first 3 exams. If stuff was important enough to put on an exam, it was probably important enough to put on a final. So if I were studying for the final, I would go through the first 3 exams, make sure I can do all of those problems, and then I would look at this review sheet that I'm going to pass out as a today and make sure I can do those questions.
So we'll get a
Well, of course, you might have to look at your notes because you might look at a problem on problem number 1 and say, holy crap, I don't remember how to do that. And then you have to go back and look at your notes to figure out how did we do that way back then. So I'm not saying don't look at your notes. I'm saying start with the exams and see how much you remember. All right. So here's what the problems in this section are going to look like. We might have x minus 2 squared over 4 minus y plus 3 squared over 9 equals 1. First thing I would ask you to do is I would ask you to tell me that what kind of graph is this? Hyperbola. How do you know this one's a hyperbola? It's got x squared and y squared, but it's got a minus in between. That's a hyperbola. So the first thing I might ask you to do is find the center. 2, comma, negative 3. The center is 2, comma, negative 3. Is this hyperbola going left and right? Or is it going up and down? No? I'm positive. It has absolutely nothing to do with the numbers. For hyperbolas, for hyperbolas, it only has to do with which one's positive and which one's negative. Which one's positive? The x is the positive one, correct? The y has the minus in front of it. These numbers make a difference on ellipses. They don't make a difference with hyperbolas. I just said it made a difference in the way the equations are written. But notice back here, nowhere did I say in this definition that A had to be bigger than B. I just said if the x is the positive one, then it's going to open left and right. If y is the positive one, it opens up and down. So I made those numbers that way on purpose just to show you that the numbers here for hyperbolas don't matter as far as direction goes. The only thing that matters is which one is positive and which one is negative. So I put the bigger number under the y to throw you off right from the beginning because I knew it would work. That's mean, isn't it? It's mean. All right, so for hyperbolas, we look to see which one is positive, which one is negative. The x is positive. That tells me it opens left and right. What's my A number? 2. A is 2 because A squared is 4. So A is 2. So what are my vertices? Which way am I going again? Left and right. So I start at my center. How do I start at my center and go left and right? I add to the x value and I subtract from the x value. So one of my vertices, if I start at 2 and I go 2 to the right, I'm going to be at 4. So one of them is 4, comma, negative 3. And the other one is 0, comma, negative 3. I start at 2 and I subtract 2. All right, how about my foci? To find the foci, I need to know the C number, don't I? Do I know the C number? I can find it. How do I find the C number? C squared is A squared plus B squared. So C squared is 4 plus 9. So C is the square root of 13. Not a nice number, that's okay. Good question. The co-vertices go the other direction. So if I asked you to find the co-vertices, there aren't any for a hyperbola, are there? Because you see what that B number did? That B number was just kind of strange. It's just kind of up here off the graph. So there aren't any co-vertices. So I found my vertices by adding to my x values. To find my foci, I'm also going to add and subtract to my x values because this one's going left and right. If this one were going up and down, I would be adding everything to my y values. This one goes left and right, so everything goes with the x values. Okay, so my foci are going to be 2, plus and minus square root of 13, comma, negative 3. I would write it that way. I would write it as one looking point, but there's really 2 points there. And the last thing I would ask you to find are the asymptotes. The asymptote has y minus the k number. What's the k number? K number is negative 3, so it's going to be y minus 3, which is y plus 3, equals, and this one has plus and minus b over a. So plus or minus. What's the b number? The b number is 3. The a number is 2 times x minus 2. There would be the 2 asymptotes. There's a formula. Y minus k. There's really 2 formulas, but it's really one. B over a times x minus h. I use that formula.
You switch, that's when it goes up and down, you switch to the A.
Yep. What's the point of the b? The only place the b number is used, well, the b number is used in 2 spots. The b number is used to find c, and the b number is used to find the asymptote. Graphically, the b doesn't have much meaning in this place, like it did in the ellipses. In the ellipses, b told difficult vertices. All right. One more quick one. An easy one. Relatively easy. How about y squared minus 4x squared equals 4? Once again, you should immediately look at that and you should immediately say hyperbola. Why do you immediately say hyperbola? It has x squared and it has y squared. One of is positive and one is negative. That's a hyperbola. What if they're both positive? It's an ellipse. When is it a circle?
1.
When the coefficients are the same. So if this was a 4y squared and a 4x squared, then it would be a circle. When's it a parabola? It only has x squared or it only has y squared. One or the other, but not both. Does this hyperbola, does it go left and right, or does it go up and down? And how do you know it goes up and down? The y is positive, so the y positive tells you it goes up and down. It's always whichever one is positive.
Okay.
So if I'd written this as minus y squared plus 4x, then it would go left and right because the x squared would be the positive one. Typically, it's written this way. Whichever one comes first is the positive one, and whichever one comes second is the negative. But it doesn't have to be. All right, I think the first thing I would do is I would divide by 4. Why would I divide by 4? Because I need to have a 1 over there to have my standard form. So I think I would divide by 4. I would have that. What's the center? 0, 0. Why is the center 0, 0? Because there's no x minus something, there's no y minus something. It's just x squared and y squared. So your center is 0, 0. That's nice. But your vertices this time. Once again, we said this one's going up and down. So I start at my center. How far up do I go? Not 4. 2. Why 2? This is the a squared number. A squared is 4. So a is 2. So if I start at 0, 0 and I go up 2, where am I? 0, 2, and the other vertex is 0, negative 2. Okay, how about my foci? I need to find C. So how do I find C? C squared is A squared plus B squared. So C squared is 4 plus 1, because if there's no number divided there really is a number, it's a 1. So C is the square root of 5. Again, to find my foci, I'm going to start at the center, 0, 0. And which way am I moving? Up and down. So it's going to be 0, square root of 5, and 0, minus square root of 5. I could have written that as one thing. I chose to write it as 2 this time for no particular reason. If it's up and down, you're always moving up and down, which means you're always changing the y number. If it's left and right, you're always going left and right, so you're always changing the x number. That's correct. So in that sense, hyperbolas are a little bit easier. Because for ellipses, we have to go left to right and up down for every problem, because we're going to find vertices and co-vertices. So ellipses in that sense are a little bit more difficult. Finally, we find our asymptotes. Minus k is plus or minus a over b times x minus h. So notice the formulas are slightly different for the asymptotes. Sometimes it's b over a, sometimes it's a over b, depending on, there it is. Sometimes it's b over a, sometimes it's a over b, depending on if you're up and down or left and right. But again, these will be given to you. Final answer is going to be y equals 2x. Because k is 0, h is 0, a is 2, and b is 1. So it's just 2 over 1. Y equals 2.
There's no plus or minus.
Plus or minus 2x. Thank you.
Absolutely, there should be a plus or minus.